But first, maybe I think it's important to make a distinguishment between AI, a deep neural network, and an algorithm.
Yeah.
Do you know the difference between those three?
So, well, difference between an AI and an algorithm is now I'm excluding like generative AI like ChatGPT that generates from itself because I don't know anything about it except for how
Wait,
to use it.
explain generative
So
AI.
ChatGPT is generative, so it can generate new stuff. Well, like all AIs can generate new stuff, but it's a different fields, and I don't know exactly.
Oh
what it is,
yeah.
but you have different AIs like
You have things that can make new data, sort of, and then you have things that can analyze the data, and that's
yeah, but
maybe
like
where you.
like in very basic like machine learning in very basic concepts, and I'm not an expert at all. I've been out of the loop.
Oh, you're a world-renowned expert.
Exactly. So please, if anyone else knows anything about it, don't judge me if I can't remember it right. But you have like the way of looking at an algorithm, you define the workings of a function and you get a result. And the way in which most AIs or most models work is you get a result and you feed it to this thing, and this thing makes your function. So instead of saying, "Oh, I have function and I want my results," you say like, "Here are the results. Now be the function, and whenever later I want a new result, I can just tell you like, oh, and here's some new stuff. Be your function again." So instead of generating responses, you're actually generating the function itself, which you don't know. That's why it's nice because with very complex stuff, lots of data, lots of parameters, you cannot build the function. You just cannot. There's too many like variables, and it would take like.
I think what you're hitting here is very interesting because the function, I think, relates to an algorithm, right?
Exactly.
Function is an algorithm, so you give it an input, it does something with the input, and it gives you an output.
Yeah.
But now, like you're saying, you give the input and the output, and it creates a function in between.
Yeah.
Actually, the algorithm that changes one into the other.
Exactly. So it makes the function. It's like if you don't know the function, you just give some inputs, give some outputs, and then it'll make its function. And so there's different ways of doing AI. Some it's like you have your input and you have your output labeled. You have like, oh, this is you have a picture of a cat and the result is a cat, and that's input outputs, and you just feed it all the way through this AI, and then after a while it starts learning the thing. But what I did, and that's reinforcement learning. That's something different, and that uses neural networks. But I forgot the deep networks were also. I think deep neural networks.
We'll come to it.
Yeah. But so what that does is it doesn't have an output, and it doesn't have it has inputs, but it doesn't have an output that's labeled to the input. So what you do is you make an environment, albeit simulated, albeit real, and so you give it inputs. It tries to do something, and then with that outputs that it tries, like you say, like here's a picture of a cat, but he doesn't know that it's a cat. Here's a picture. Try to guess what it is. If it's a cat, then we'll give you some points. The environment change. Yeah. Well, with the picture it's difficult because that's not a use case. But the environment will change. Your simulated environment will change.
I think maybe to for the listeners, you give it like kind of weights. Like, if something is resembling a cat, you say, this one is more true than the other one.
Yeah,
on that kind of sense, it can make a sort of balance on, if these features are present in the picture, then I can definitely say it's a cat. Yeah. If they are not present, then you say that you give feedback to it from no, this is not present, it's not a cat.
Yeah. So and so these weights you call that's something that it changes itself. That's called backpropagation. And so what you do is you have, for example, I'll give the example for reinforcement learning. I give an example for my thesis, and it's an environment of a traffic. So you have a traffic intersection, you have cars coming from all ways, and so the AI is actually controlling the traffic light based on legal limits. So it can't like green on both sides. You can just tell them to switch or whatever. And so what he does, he tries some stuff, and at first, so you let it run for like ages and decennia with random cars coming, and he tries some stuff, and so he doesn't know if it was good or bad that it switched from green to reds. He doesn't know it because you don't have label data. but you have the result is how many cars went through this intersection for 1 hour, something. And so that's the result. And if the result is good, then it will look at this result, say, the AI will say like, how did I get to this result? And it's like, you've probably seen a picture of like a dot and then like, oh, dots, and then again a dot. So that's input, output, and all the fields in between. So it gets the output and it says like, okay, I used like this line and this line to get to my output. So I'll increase these lines because they were good. And all the lines that said, no, you didn't have to switch, they were bad, so I'll decrease them.
Yeah.
And so that's how you get like these weights, or this, like how thick a line you have.
Yeah.
And so after a while, you see these correlations of like, oh, apparently how many cars were in this intersection was a very good indicator of when to switch. So this line from the amount of cars to the output is a very thick line. And so that's how you get these thick and these thin lines. That's
And
how you
I
train
think
this model.
like all this is kind of based upon the human brain, right? Like neurons that produce a good output will also get a better connection with each other, so that you get easier to the output. For example, this is very true for addiction. If I'm smoking a joint, my output will be very happy very fast because my links are very tight and very well established in that sense. And in that way, it's similar for AI. It can correlate, or it can make a perception of, okay, my input was this, and this was the output that you guys labeled as correct. This connection must be very good. So it enforces its own connection to make this kind of calculations or whatever faster, I think.
Yes.
It's in easier terms.
Exactly. And so that's the learning phase. So what you do is you train it for so long that after a while it's converges to a point where it thinks like, okay, I think my lines are pretty much what it needs to be. And so then your AI trains. And what a lot of people don't know is that when you use an AI, when you use a model, you're not training it anymore. Just like, oh, this is now the brain. It's not changing anymore because we don't want to change its behavior. It's just like, oh, we like this. So then you implement it, and then you start like, oh, okay, now handle all these problems with the lines it made.
You can see it actually like an education, maybe. Like people learn things in school and in high school and in university. And once you're like fully built, you're all the connections, the right connections with information to that one, to that sense, then you start actually fixing the problems. First, you're learning about them, what is a good thing, what is our bad things, and then they feed you actually the problems they want you to solve.
Exactly.
So I think for me it was, I can give maybe a little bit easier example in that sense. I also did something with deep neural networks in my master thesis, and I basically labeled limbs of a mouse. So I would say this is a paw, this is an arm, this is a head, this is a nose. I would label these on these kind of pictures. I would feed it to this deep neural network, and then I would give fresh data that I haven't labeled yet, and I would see how does this, how can it find these kind of limbs and nose and stuff. And then I can say, oh, I train it well, or I maybe have to retry and train it again. And that's important. That's AI is one thing and algorithms are one thing, but the training is also very important because I don't know if it's now different, but in my case, you could not train it infinite. Like the more you train it, the more difficult it became for the AI to make these good connections.
Yeah, so after a while, after you've trained a long time, the new things become less powerful. Like at first, it learns with a very big margin. Like, oh, if it's right, I'll double this line, and you have these big changes. But then after a while, changes you apply to the line, to these weights, become smaller and smaller. So then like it converges, and sometimes it converges to the wrong, and then you have to like all these. But like I was thinking about your analogy of teaching, and I think that the two models that I know is so your model, that's I don't actually.
Mine was actually like how do you call it?
Deep neural network. It's
image recognition was
image
just
recognition.
mine. Was just mine one.
That's a bit like going to school and someone's there, and he's telling you how to do something. So he's telling you, oh, you have to do this, you have to do this, you have to do this, you have to do this. And so you're trying, and after a while, you're just like, okay, now I take that what you learned to me is the thing to do, and then you'll do that.
That's the algorithm or the set of algorithms.
The brain.
Yeah.
But then the other approach, and that's not the other approach, but one of the other approaches, that's reinforcement learning, is you just like you're just left out in the world, just like, oh, go ahead, do some stuff, and everything you do, you just try, and if you fail at something, we'll judge you. So we're not teaching you anything, but we'll judge failures, and we'll applaud like good behavior. And so then you're like going on your own, and you're just like trying new stuff. And the good thing is you don't have to have labeled data, but the bad thing is, of course, probably that it's way more complex to find good behaviors. Because you're like, what if I'm just like as a kid walking on the street? I'm like, I don't know what to do. I can do so many different things. So it's more difficult to find like this one behavior to do.
I think a good analogy for this, so we have the reinforcement learning and the how do you say the labeling and then reinforced learning, but you also have like the solo reinforced learning, I would say. And maybe a good analogy for this one is actually cooking. I think you have all these ingredients, you can put everything together, but it doesn't make a good soup or a good meal. And people say, this was not so good, maybe you should try this.
Yeah.
This was also not so good. And then eventually you kind of get the right taste and the right texture and the right combination of all these different kind of ingredients.
Yeah, so you're trying and you're basing your results on the response of the people judging you. While the other one is just following a cookbook and like reading 1,000 cookbooks and trying to replicate 1,000 cookbooks until you know how to cook. Yeah. And those are like two approaches. But I think the generative AI like ChatGPT and like the big breaking technology, they use something else. But I don't know. I haven't researched it. Yeah.
Okay, so maybe I can use these analogies first. So an algorithm, I would say, is like a neural connection in our brain. You have one input and you get one output. It does something with that input. It may be related to a memory you have, if I use this analogy, or something else, or it's based upon what it's learned or what it's programmed like.
Yeah.
Then we have a deep neural network, and these might also be called like a weak AI. So basically what this does is like it has many artificial neurons. They all start from one input, and each of these neurons also connects with the next layer of neurons. So every neuron of one layer connects with one neuron of the next layer.
But is that with all AIs?
Maybe, but this is just it converges back to one output, so maybe that's the difference. But basically we have these layers of neurons, and they're all connected with each other on every possibility, and the connections that are actually producing the good output are getting more weight or getting stronger. And that's how a weak AI would get one input and also give one output, like an algorithm, but it is like with hundreds of algorithms in between, actually. So for example, my labeling of these mice would be a weak AI. It's just recognition of where limbs are. It cannot use comprehension, or it cannot use the environment to understand what is going on. You just give it one task and it performs one thing for you. Then we have these strong AIs, they would say, and these are like the ChatGPT. It's like models, it's like understanding language, it's making a sensible answer. It's not just it has to imagine something, you know. That's what's a bit with try stuff and get a result. We cannot envision what such an AI would give us, but we could envision with the mice what the answer would be, you know.
Yeah, but I don't know if there's a lot of difference between them, because I think that all the AIs are the model you explained with like the neurons, and okay, it doesn't have to converge to one point. You can have a lot of inputs and a lot of outputs, and you could have multiple layers all like crossing, and it can be huge. But I think that the models themselves still represent, I think still represent themselves as these connection of neurons that all have weights. The thing is, like, I don't know if it actually thinks for itself. It just finds correlation for things we would never think. Like, oh, what if I have like input 237 and I combine with input 538 by this way, and so this is how it like finds connections, which I think is how our brain also finds connections. And it seems like it's thinking, but I think it's just still like everything is still just sort of a function, sort of an algorithm where you put data in and data comes out. That's like you say, I think there's a lot of like extra stuff added to it. Like one big thing that I think they have now is context awareness, which was a big thing that I also researched, where normally it's very difficult to be aware of context. And that was like this big blockage in AI development.
To put it in easier terms, maybe like you could give it one task, but if you asked another task, it would kind of forget the first task.
Exactly.
Or it would not learn or remember the things you asked or asked of this AI before.
Yeah.
And that, I think, is one of the big breakthroughs for ChatGPT. And it can really encapsulate what you said and asked before, and it can kind of create an idea of what you're searching for.
Yeah, but I think it's more than just history of your own conversation, because I think, and we take it for granted, context of like, what if I say like, oh, what's the, I don't know, like a programming term, like what's the function to, I don't know, generates blah blah blah, I don't know, whatever. Like, if you could ask this to a function, it would say like, I don't know what you're talking about. Do you mean maybe this? Do you maybe mean this? Do you maybe mean programming language? Or do you mean, like, it knows about how we formulate simple questions with very little additional information. Like, I'm not talking about like where I live, what I want, but it still can like think like, okay, I think with this information that you gave me, you're talking about programming or you're talking about sports, which is not always the case. And that, I think, and I don't know how they did it, it's not from a history of your previous conversation. It's just like what the most like common ways of asking that question based on that context. And I think like it's not that it knows all the not that it knows exactly what you're thinking, it just knows all the contexts that there are, and it just analyzes all the data that there is, and that's how it can like relate to, like, it seems like it has a context, but I just think it's very, very, very big data combined. But like I said, I'm not sure.
In that sense, are humans not similar in that way? When can you say that we can see a context?
Yeah.
Because it's also for us based upon experience most of the time.
Yeah, and
we can understand emotions and context because we've been there before.
Exactly.
And I think it's similar in that sense for AI. That it just trained very well in that sense.
Yeah.
And it can understand the context based upon what it's trained on.
Yeah, exactly. And I don't know, it's crazy that it can still like acts as if it understands the context, which I think it doesn't understand anything. It's just like you said, it's just trained on a lot of data.